Hey Physics Onliners, welcome to Flippin' Physics. What we're going to learn today is something called significant digits and uncertainty. So I'm really going to introduce you to a meter stick and how accurately you can read a meter stick. So I have these trusty assistants here like this, and I have a meter stick. So the first question I'm going to ask them is, without really looking at a meter stick more than 5 seconds, about how wide is this table? I mean, just look at it. How many of these is it, and how would you make that statement? Jen?
About 2 meters.
Okay, about 2 meters. So the best they could do without the actual instrument would be to say about 2 meters. So how many SigFigs is that? 1 SigFig, the number 2. Okay, so make sure you read the reference to the rules of SigFigs. Non-zeros always count. Zeros count if they're in between. And zeros are real weird. They don't count on the left side. So 0.00405 only has 3 SigFigs. But if you put the zeros on the end of a decimal point, they count. And if there's no decimal point, they don't count. So it's a little confusing. So make sure you read those rules. All right, so now if I give them a meter stick, check this out. I have a meter stick, but the meter stick's kind of special. It doesn't have any markings on this side. It just says meter. Okay, so now come on over here and see them measure. What I want you guys to do is measure as well as you can the length of the table. Now promise me you only look at the top of the stuff, okay? And then so it's definitely 2. So now 2's not a guess anymore. Go ahead. And then 2 is not the guess. Okay? Now they actually take a guess beyond the 2. So what do you guys think? Go put your eyes right over there and kind of eyeball what the guess would be. Now you're going to want to look at this side, so no cheating. Just look at the top. What do you guys think?
About 2.4 meters.
Okay, about 2.4. So look and see what that meant. 2.4 meters meant they took a guess to 1/10 of the smallest increment on the instrument. So this instrument, for a minute here, is going to only have a meter as its smallest increment. So they were able to take a guess to 1/10 of a meter. They said 2.4. Okay, now I'm going to flip this thing. So now this meter stick has, what are these called?
Decimeters.
Decimeters, or tenths of meters. So decimeters is the increment. And remember, the rule is you can always take a guess to 1/10 of the smallest increment. So if you guys would humor me and do the exact same thing over again, that would be awesome. There's 1 meter. That's not a guess. Definitely 2. That's not a guess. But now, watch what happens. Look at the very top. And the guess is not 2.4 anymore. We're sure about the 2.4. Now, Jen, take a guess between the 4 and the 5. It's
3?
2.43. Okay, that's her guess. It could be 2.44, or it could be 2.42. But Jen guessed 2.43, and I'm cool with it. So when we learn about uncertainty next time, you're going to probably state this as 2.43 plus or minus 0.1. Get it? Or 0.01. Because you're guessing. Now, what are you guessing at? These are decimeters, but what did you just state that as? You said 2.43. What's the 3? 2.43 meters. Where's the 3? Isn't that 100th? Well, what's that called?
Centimeters.
So even though you have the smallest increment is decimeters, you actually guessed at the centimeter mark. Okay, see how that works? It's always 1/10 of the smallest increment. All right, so here we go. I got a meter stick here, but I don't know if you guys can see this, but this is in centimeters now. Now the increments are centimeters. So guys, if you would be so kind as to measure that whole thing over again. But now they're going to promise to use just the top of the meter stick. There's 2. That's not a guess anymore. And 2.4, that's a definite. That's not a guess. And 2.43, Jen was right. It was at least 2.43. But now take a guess between the 43 and 44. 2.43.
5.
2.435. Or 4.
Or 4.
Or 4.
Yeah, maybe
5 or 4. It depends, okay? So you would say 2.435 plus or minus 0.001, right? All right. And what are you guessing at? These are centimeters. Where's the guess?
Millimeters.
Millimeters, 1/10 of the smallest increment. Very good. All right. I have here a real meter stick now. Finally, we got to what is written on the meter stick you probably got in your kit. And that is a meter stick has millimeters as the smallest increment. All right? So if we measure this and do the whole thing over again, we're going to be able to measure as good as a meter stick could possibly get. So it's definitely 2. It's definitely 2.4. It's definitely 2.444. What do you think? 2.43. 4.4 or 4.5? You can make that guess. So they're actually guessing the millimeters in between. So what's that? A tenth of a millimeter. There's no fancy name for that, but it's a tenth of a millimeter. Okay? Now, just a little side note before we stop, and that is this. What I just probably told you was a lie, in the sense that that's as good as a meter stick could get. But let's be honest. The first lab we're going to do is all about uncertainty. Let's be honest. The minute these people lifted up the meter stick and put it down again, they lost accuracy. They lost precision, I should say. So the minute they open it up, put it here, and put it here. So honestly, a meter stick could be read to a tenth of a millimeter under really ideal conditions, like something that never got bigger than a meter, so that you could actually lay it down and hold it there. Then it's good to a tenth. But the minute they lifted it up, like you're going to do in your lab when you measure dimensions of a room, you have to be honest and say it's not quite that good. Okay? All right, so that's a good introduction to SigFigs.